The Phoenix Biomedical Campus is a 37-acre mixed-use campus on the edge of the city of Phoenix's downtown core. It is home to the University of Arizona College of Medicine Phoenix, as well as public and private academic, clinical, and research institutions. The campus provides researchers, educators, and innovators unique opportunities for interdisciplinary collaboration in the biomedical industry. The City of Phoenix, in partnership with the Arizona Board of Regents, commissioned a master plan to identify the programs, building types, space requirements, and connections for the new Phoenix Biomedical Campus. The first implementation of the campus master plan was the 268,000 square foot Health Sciences Education Building. Completed in 2012, the 6-story HSEB is a physical manifestation of a new interdisciplinary approach to health sciences education. The second implementation of the campus master plan was the Biomedical Sciences Partnership Building, a 10-story state-of-the-art research facility. The 245,000 square foot building features 6 floors of wet lab space, 2 floors of dry lab space, and 2 seminar rooms. It is home to the Center of Applied Nanoscience and Biomedicine.
An unusual aspect of this campus is the idea that the clinical, academic, and research functions, each of those kind of program elements, were designed to be co-located on the campus from the very beginning, as well as to be physically interconnected. So the master plan devised a way that each of those different functions could be placed on the campus with specific capacities, and then we designed through the master plan a whole series of interconnections between the actual buildings. So that's the bridges, the mixing bar, and other devices like that. Based on our concept of having very minimal interiors, the idea was to also make sure that these are warm and inviting places for people to spend plenty of time. And one of the devices to that is we like to include something like wood. So slotted wood panel system and the perforated wood panel system helped achieve both the visual look that we need and also improved our acoustic benefits. And when they're all put together, it's sort of the planar character of all of those products is a really great complement to all the other textures in the building. The interiors of these buildings is a very important design aspect of this. This is really the hardest part to get right. The nature of the open labs often creates noise and other issues. The Gypsor product helped us achieve much better acoustic benefits. We were able to locate the product specifically in the areas that supported seminar, open office, and the lab functional areas that might have noise issues. The concept behind the campus, of course, was for it to be very regional, very site-specific and climate-oriented. Part of that was that we needed to make sure that we chose exterior skin systems that would support that. The idea of geological impressions were very important, and then the use of copper is a very sort of perfect material to use in our climate. So the combination of those was the idea of the striated panels for the campus. Those are self-shading, they have great texture. The color of the copper changes over time, which is perfect. That led us into the design, and it went through COVAC that we were able to take a design idea and truly implement it to the highest levels of our desires.
It's a panelized wood grill system that attaches to a standard 15/16" T-bar, which allows for all the mechanical, electrical devices to set into the T-bar and keep everything aligned with the blades of the panels. The system allows for a large blade to be utilized in the space to create the linear look that incorporated in with the lights, but also gave the owner accessibility. There was a lot of coordination between the design team, the general contractor, and ourselves. We had several mock-ups which allowed other trades to incorporate their devices months before the actual installation. That way everybody knew the challenges ahead and those were worked out before the actual installation. Some lessons learned are the panels in the seminar room are secured with caddy clips and hex nuts for maintenance people to be able to access easily and reinstall time after time for the life of the building. One of the things I wish we would have done is incorporated that throughout the entire first floor, because since then we have gone back to create access panels where they weren't originally put in. Acoustic wood panel. It allows for the natural beauty of the wood, but also to give the acoustics in the space. It's attached to the substrate with Z-furring. which allows removal and replacement of the panel. There were many steps taken with regards to layout. This was a perforated panel with a standard border, so no panel could be field cut. So we had to coordinate with the millwork behind it and also with the field conditions to ensure that every panel was exact to keep the border around the panel with the perforations. One of the things that was important to the design team on this was that all of the wood coordinated with each other. We knew in the field there would be some field sorting that needed to be done. Our field installers worked to match the panels that we had, not only with each other, but with the millwork that they would be abutting, to ensure that it was a consistent look around the entire space, but still gave you the beauty of each individual panel of wood. Lessons learned. One of the challenges with a perforated panel with a standard border is that there is no field adjustment. To ensure that everything is plumb and square before you pre-measure, including making sure the floor is level and what that benchmark in is key to installing the product successfully.
Working with the representatives from GIPZORB out of Seattle, Washington, they helped me understand that this product did not come in standard dimensions. This was all in metric. So understanding that our stud spacing was different than your typical stud spacing. We used a couple of different size sheets. One was custom made for this job to limit cost and material waste. Once a piece is cut up, it's hard to reuse that piece of gypsum in another location. The biggest concern with installing this product was the layout of our studs and ensuring our elevations were correct. Any deviations in the soffit would be noticeable with the holes not lining up on corners. The biggest step prior to installation was drawing all this up in AutoCAD with the different sheets, kind of like a map for our guys to follow, understand, and install in the field. So a few lessons learned while installing this product. One was the layout is critical, understanding where your start and stop points are. Second one deals with taping. Corner bead, we had to use the smallest corner bead possible. Understanding that the vertical corners don't get corner bead, just mud. Our guys aren't used to that. Understanding that there's a black felt behind this perforated drywall, knowing that you can't get drywall mud in the perforated holes. And talking with the representatives from GIPZORB, using a fine nap roller, lightly brushing the paint on, going over it a few times to ensure the product looks the same. And also elevations where the top of the drywall meets the concrete deck above. It wasn't really realized that the concrete isn't level, so knowing how long runs of drywall is going to look when the concrete's sloped and how to finish that top row of perforated holes.
BPB was really kind of a sister job to HSEB. A lot of the design aspect of how to make this complex of a panel started back then. We had to purchase a press brake, specific press brake, to be able to make this type of a panel. 90% of all sheet metal single skin panels start out with a flat, square piece of metal. First one that we've ever done that is, it starts out in a flat, funky shape. It's not square. And how do you create a square panel on that? What we did was a lot of testing, a lot of trial, and a lot of error on that. We spent so much time on the design aspect of it that really in the field it was a no-brainer. The complexity was all in the releasing and fabricating of the product. Our field didn't have to think about how do I need to trim this panel or how do I got to make these two corners come together. Product is installed from the bottom up. They're fastened from behind, so they're used with long drivers and shafts to kind of reach in behind the panels and secure the panel. And the next one kind of goes on top of that and kind of gives it a concealed method of attachment. Lessons learned from HSEB to BPB was on some of the bigger panels, we went with a thicker gauge to help minimize some of the oil canning. The thickness of material helps determine the amount of oil canning that will be present. There's always a way to accomplish something in some form and in some way of what architects are coming up with these days.